Now, in this case, what does he say? He says that we have, let me just see if I can move this one up. Yeah, let me try to move it up so that there is some space. Okay, very good. So now he says the brass bar shown in figure below is made of what? Is part of a conveyor that transports components into an oven. Initially, when the temperature is 15 degrees Celsius. So he gives me the initial temperature, is it not? He gives me what does he give me? He gives me T1. T1 is equal to 15 degree centigrade. Okay, there is a total clearance of 0.25. Here you see there is a clearance of how much? Delta. That is 0.25 mm clearance is there. Okay. Uh, Describe what happens when the temperature increases from 15 to 90 degrees Celsius. So T2 is 90 degree Celsius. So what will happen to delta T? Delta T is T2 minus T1. That is 90 minus Hamstash. That is how much? 75 degrees Celsius is delta T. Okay. Take the modulus of elasticity he has given us. How much he gives the modulus of elasticity? E is equal to 110 into 10 cube megapascal, and then coefficient of linear expansion as 20.5 into 10 to the power of minus 6 per degree Celsius, is it not? This is what he has given us. So all information is there. Now what happens is, now see, let me make the picture very simple here. Okay. So now in case if it is there like this, if you allow it to expand fully, this is your bar. If you allow it to expand fully, it will go up to this point. This is your total delta L, is it not? So now what has happened? You have kept a wall here, right? So because there is some space here, what is this space? This space is delta, right? This is what? This is your total delta L, is it not? So now what will be this value? Delta L naught. I can write delta L naught is equal to delta L minus delta. Correct, Shamam? Okay. So now delta L naught is equal to delta L by delta. Now what is the value of delta L? Delta L you can easily find out. Let's just go. What is the formula for delta L? The formula for delta L would be alpha delta T into L, is it not? So let me just go here. I can write delta L is equal to alpha into delta T multiplied by L, is it not? What is the value of alpha? He gives me the value of alpha as 20.5 into 10 to the power of 6. 20.5 into 10 to the power of minus 6 multiplied by delta T is how much? 75 multiplied by what is the value of L? Let me go back and check. The value of L is how much? The value of L is 250 millimeter, is it not? So let me just go back, multiply and write 250 millimeter. Okay, so this is how much? This is 20.5 multiplied with 10 to the power of minus 6 multiplied by 75 multiplied by 250. That gives me 0.38 0.39, you can say. Okay, 0.39 millimeter is free expansion. Okay, expansion prevented is how much? Expansion prevented is equal to 0.39 Nagas delta. That is 0.39 minus 0.25 is the clearance, is it not? 0.39 minus 0.25. This is 0.14 millimeter is the clearance prevented. Okay. So now we know the formula. What is the formula now? Let's just go back here. Let's just go back and check what is the formula here. Just see the formula. So we already Find this value now. We already find this value. This is already done. Okay. Now we are left with what? We are left with PL by A. You have to just write. Okay. P by A is sigma. Sigma into L by E. Okay. Sigma into L by E. Let me just go back and write here. So I have to write sigma into L by E is equal to 0.14. Therefore, sigma is equal to 0.14 multiplied by E divided by L. 0.14 multiplied by E is how much? We already give this value in the problem. In the problem, it is 110 into 10 cube, is it not? So I can write it as 110 into 10 cube divided by L is how much? Methane comes in. What is this answer? 0.14 multiplied by 110 multiplied by 10 to the power of 3 divided by methane comes in. That gives me 61.6. 61.6 Newton per millimeter square. This is the stress induced in the material because of partial restriction. If it is allowed to expand fully, there will be no stress. Okay.